Well, good morning, everyone. Welcome to our Database DevOps webinar. I think their title was Extending Database DevOps with Redgate or something similar to that. I forget what the title, they changed the titles on me, so I'm not 100% sure what it is, but it will be up on the YouTube channel when we get there. Before we get started, real quick, just to let you know, we are recording this webinar so that we'll have it posted later. If you have to drop out or you come in late or something, it will be there. We are taking questions, so the questions are in the little control panel from GoToWebinar. Please feel free to ask questions in there, and I think I've just answered the first one from Pedro, so I'm glad I did. We are recording it, and I'll try to answer them as we go, or I'll maybe put some questions out to Arne, who'll be doing the demo today. I guess that's about it. You know, if you've got any more information or any other questions, please feel free to contact us at Redgate. You can contact sales at Redgate or DLM at Redgate, and we'll go from there. So I'm Steve Jones, and I work for Redgate Software as an evangelist, but I've been a DBA and developer for many years. As a matter of fact, I've been working with SQL Server for 25 years. I've worked in a variety of big companies, small companies, as both a developer and a DBA across my career. All my contact information is up on the screen. My blog is there, and email and Twitter. Please feel free to get a hold of me if you'd like to. And then Arne, why don't I let you introduce yourself?
Sounds good. Hey everyone, I'm Arne Eskandari, and I've been with Redgate for almost 6 years now. And as a sales engineer, I've worked with hundreds of dev shops, helping them go through the DevOps journey on the database side by providing an assessment of their existing process, making recommendation on the next steps, both in terms of process changes and tooling in order to implement a true DevOps process. So here's my contact information. So if there's anything we can do to help you with this journey, then please feel free to reach out.
All right, thanks, Arne. So our agenda is, I'm going to talk just to a few slides. I'll try to go fairly quickly here, and then really we want to get into the demo and have you see how this works, how Redgate has really done a lot of work trying to get the databases into a CI/CD DevOps process, and then hopefully get lots of questions from you and that we can answer and we can demo and show as we go along. So let's jump forward to a little bit about Redgate. While I talk to this slide for a minute, I'm actually going to pop up a little poll because we're curious if you use any of these tools. So please feel free to answer the poll while I talk. Now, Redgate has been around for 17 years now. It started in 2000, and as a matter of fact, Redgate was the first customer of mine at SQL Server Central when I was independent and selling advertising. So I've known Redgate kind of through their entire history, as well as all the time SQL Server Central has been around. Our goal is to build these ingeniously simple, really useful tools that help you build software. Right, so our goal is to help you build software, and we sell to technology professionals all over the world, to lots of huge Fortune 100 companies, and you know, our philosophy is just to make you better at your job. And part of what Redgate does, in addition to selling software, is that we also support the community with simpletalk.com, which is a technical journal for Microsoft Stack professionals and developers, DBAs, administrators, and SQL Server Central. We're a little more focused on SQL Server Central, but Redgate owns both those sites, and they support the community in that way. And then we also send around various employees to speak at different events. So I travel around, Grant Fritchie travels around, Arne, you've been at some conferences, some of our developers go around, so we do our best to support the community as well as sell software. So looks like most people voted, so I'll close the poll and then jump over into the next slide. So DevOps has been around for a while. As a matter of fact, I've been doing this type of process through most of my career, though we didn't call it DevOps. It was really just, it was Agile at some point, and it was, just trying to be more flexible and adaptable and just smarter developers. But really, the idea is that, we move smoothly from development to operations, we work together, and we deploy software. Now, databases are challenging because unlike most application software, databases carry state in our tables. So when we talk about the challenges of databases, most of the challenges really fall around databases. All of our other code, like stored procedures and views and functions and assemblies and anything else that's code, is very similar to C# code or Python code or Java code or any application code, in that we can deploy a new version, deploy an old version, we can roll back and move forward in version control. We can do all these kinds of things without worrying about what we previously had, right? We can always replace it with a new version or an old version easily. But with our tables, because we have this data, we can't easily modify the tables. It's time consuming, it's complex. We can't drop a table and add a table back because we need to keep part of that data. And so it becomes important that we ensure that we carry this state around. Now, when we're trying to do database deployments and we're trying to roll things out, we have all kinds of issues, all kinds of things come into play, and I'm sure many of you have run into one or more of these. Often, coordinating the database and the application is challenging, but it's more that trying to just track which changes we want to deploy at what point in time, whether we're going with an application or ahead of an application, is a problem. And then tracking those changes is problematic because typically we haven't had version control for our database code. Rolling back certainly is an issue when we've got that state to deal with. When I've got data, those are issues as well. All of these things, and then as well as the need for the DBAs or sysadmins to maintain stability in the database, mean that the database is a bottleneck. We want to move slower in general in the database, but we don't have to. And so rather than have any of these issues come up and allow deployments to be these big stressful events that happen infrequently and a lot of they're very resource intensive, we want to find better ways to do that. And so part of what Redgate is doing is trying to implement DLM, which is Database Lifecycle Management, into DevOps and into your deployment process. And the idea here really is that we want to automate as much as possible. We want repeatability and reliability and predictability over what's going to happen when we deploy database changes. So we know that when we're going to make changes and when we have to move them from our development database to other databases, we have a way to do that we are confident in. Not only we're confident, we provide some visibility. So we want to make sure that the sysadmins know what's coming, the developers know the impact of changes, and that we work smoothly together. Part of this means that we want to deploy smaller units of change, less changes at a time at a faster rate. You don't have to go faster. Typically we go faster because we want to get feedback on our changes from customers, but the idea is that really you deploy at your pace, whatever that is. So we want to provide you tools to help you automate database deployment so that you can move at whatever pace is appropriate for your organization. Now, there's a State of DevOps report that's done every year. It's been done, I think this is the 10th one that they've done. And it's from a number of very talented programmers and companies that have had a lot of success in deploying software. They deploy at not only high rate, but at a high level of quality, and they meet their business needs. And what they typically find is that when you adopt a DevOps style process, which isn't completely defined as do ABC, it's more of an idea. But when you do that and you use well-known practices such as version control, continuous integration, automated testing, continuous delivery, or continuous deployment, you end up deploying changes more frequently, so more often, with which very, very fewer bugs, very, very fewer issues coming through. You don't have problems in deployment or failures in deployment, and you don't have bugs reported back to you. Now, this could be inside your organization. This could be deploying software out to customers. So Redgate employs a DevOps process with all of our products, and we end up deploying like SQL Prompt deploys hundreds of times a year. SQL Compare deploys, I think, every month or every 2 weeks. SQL Source Control deploys every 2 weeks. DLM is a little bit slower, but we're deploying changes on a regular basis so that we're always ensuring that we're fixing issues that somebody might have found, or we're adding small pieces of functionality. And that means that we increase our profitability and market share and our productivity, and our customers love it. And the same thing happens in plenty of other organizations that do the same thing. When they find that they can deploy on a schedule that meets what their customers need, whether they're internal or external customers, they tend to perform better as a business. So how can Redgate help you here? We've got a lot of tools, and they plug into a whole software development lifecycle, so I'm going to let Arne take over and describe how this works.
Sounds good. Thank you, Steve. So this diagram basically represents a typical development or change management lifecycle. I guess in this case for databases. So starting from the left, we start in development. The developers make changes to the database. You get the changes into source control, which basically is the source of truth, and then you validate the changes that you put in source control through a CI process to make sure that all the schema is still valid that is in source control, and that there is no compilation or syntax errors. You can also run some automated tests as part of your CI process, and once the build is successful, then you can use the artifacts of that build as the source of deployment going into your hiring environment through a release management process. So the middle row here basically is the Redgate tools that you can use at different stages of this process, and the bottom row is the infrastructure and the platforms that we actually plug into. So, for instance, for today's demo, we're going to be using Git as our source control system through GitHub, and we're going to be using Jenkins as our build system, and Octopus Deploy as our release management tool. So the demo is basically going to be this process end to end. All right, so now I'm going to go ahead and switch gears here. And let me just share my other screen here on this side.
You're like me, you have too many screens, don't you, Arnie?
Yeah, exactly. I have 3. Okay, so now hopefully you can see my management studio okay. So we'll start up in our development environment. So I have this database here called AdventureWorks 2012 Git. This database represents my development environment, so I'll be making all my development changes to this database. And I also have 3 other databases that represent my higher environments that I'll be deploying to. Everything's currently set up on my machine for the purpose of the demo. That's why I have everything on a single instance of SQL Server. The first thing you notice with my development database is that the database icon is green. This is an indicator of the database being linked to source control through our SQL Source Control plugin, which is what I have here in the middle pane here. So SQL Source Control acts as a bridge between your databases in your development environment and your existing source control system. So in my case, I'm using Git as my source control tool, and you can see my database is currently linked to source control. Now, when you're working with Git, obviously you have 2 repositories. You have your working folder, your local repository, and then you have the remote repository, which in my case is GitHub that you would be pushing your changes to. If I show you my GitHub real quick here, this is the folder structure that we store in source control for your database objects. So there's a subfolder for each type of object, and then within each of these folders, we go ahead and store the create scripts for each individual object. So that way we can actually keep track of how individual objects are changing over time, and then that gives you the opportunity to take a look at the history of either individual objects or the database as a whole, either for troubleshooting purposes or for rolling back purposes, or if it's just a simple audit trail. So my database is linked to my working folder, which is my local folder. So if I go to my setup tab here, you can see it's currently linked to this repository, which is sitting on my local drive. So I'm going to go ahead and start making some changes to this database, and then we'll get the changes into source control and all the way to GitHub using our tool. So another thing that we're going to cover as part of this demo is branching with Git. So currently the only branch that I have on this database is my master branch. And here you can see SQL Source Control at the top right corner. It shows master as my current branch. So I actually don't want to make direct changes to the master branch, so I'd like to spin up a feature branch and then make my changes to that feature branch. And when I'm ready to actually run a build or deploy to the next environment, I would go ahead and merge those changes into master. So that branch currently doesn't exist, so I would have to go ahead and create that branch here on my database. So for those of you who are new to Git, branching with Git is actually very easy and straightforward. So unlike the other centralized source control systems where a branch is a specific subfolder, with Git, branches are basically just pointers to individual commits. So here's basically a simple diagram that describes, you know, my current branch, which is the master branch, and it's currently pointing to this most recent commit that I have on my repository. So we would now want to go ahead and then introduce a new branch which is basically just simply a pointer to a commit. So instead of creating subfolders in Git, you're just simply creating these pointers that point to specific commits in your repository. And this makes it really easy for you to actually spin up branches and work with branches in Git. So now I'm going to go ahead and create that new branch. We call it feature A. So I'm going to go ahead and do that right now. So to do that, I'm just going to use a Git client tool, such as SourceTree. Makes it really easy for you to work with your Git repositories. The other option is just to use the command line of Git, whichever you're more comfortable with. So I'm going to go ahead and create a new branch here. We're going to call it feature A. Okay, so now you can see feature A is created, and we're currently on the feature A branch because that's the one that is highlighted. So feature A is now pointing to this commit in our repository. So if I go back into my SQL Source Control tool, now you can see the current branch that we're on is the feature A branch. So we're on the right branch. Now we can go ahead and start making some changes to our database. So I'll start off by making a couple of changes here to a couple of my objects. So I'm going to go ahead and actually, before making changes, you can see here it gives me the option to create the upstream and push that branch to my remote repository. So I just created the branch locally on my local repository, but it doesn't exist in GitHub. So I'm just going to use this option provided by SQL Source Control to also create the same branch in the remote repository. So if there are multiple developers wanting to work with this branch, then they can start pushing changes to that branch. Okay, now I'm ready to go ahead and start making changes here. So let's start off by modifying an existing object here. So let's say we want to modify this get context serve procedure. And I want to add a couple of columns to this select statement. So we also provide SQL prompt, which is one of our productivity tools. It provides you with improved IntelliSense as well as code refactoring, formatting, and a few other productivity features. So here I can use the column picker of SQL prompt to simply pick the columns that I want to add to this select statement. So I want to do middle name, person type, and the title. And I'm going to use prompt to format this as well. So really easy to work with, and I'm going to go ahead and make this change. Now, on top of schema objects, you can also make modifications to, you can also keep track of changes that you make to data in your lookup tables or your reference tables. So that's basically tables where you make data changes in your development environment, and you push the same data all the way to production. So to do that, you can simply right-click on your database, go to Other SQL Source Control tasks, and click on Link or Unlink Static Data. And this will provide you with the list of tables that you have on your database. And from this list, you can select the tables that are considered as reference tables or lookup tables. We only recommend source controlling data in your lookup tables because there is no point source controlling data in your other transactional tables where the data, only stays in development and doesn't even need to get deployed to any other environment. So for the purpose of this demo, I have these two tables, address type and contact type, as my lookup tables. So any data changes I make to these two tables will also be tracked as part of our source controlling process. So I'm going to go ahead and insert a new record in one of these tables. So again, using prompt and in snippet manager, I have a snippet for insert into. So I'm going to insert into contact type a new type of contact. So I'm going to call this the Redgate DLM demo audio. Okay, so made a schema change as well as a data change. Now I'm going to go ahead and commit these changes to source control. So one of the principles of continuous integration is that you make commits to source control regularly. So if you've made hundreds of changes and you try to commit them all together into source control, then that kind of defeats the purpose of continuous integration and continuous deployment, because you're still, putting a large chunk of changes into source control at a time. So if anything goes wrong or if there's a bug, then the troubleshooting those changes would still be very time-consuming. So here is the report of the changes that we made to the database that we need to check into source control. So the first one, you can see it shows as a data change to the contact type table. And here at the bottom, it shows you exactly what's different between your development database and what's in your local repository of Git. So we store data as insert scripts in source control. So you can see all the records are identical, except that new one that we just added to our table. So, and the same for the USP get contact store procedure. So here at the bottom, you can see what we have on our development database on the left side and what's already in source control on the right side. So those new columns are going to be added to the create script of that store procedure in source control. And when it comes to deployments, we actually rely on our compare engine to basically run a comparison between the state of the database that is in source control, so basically all those create scripts and the insert scripts, against the target databases that we'll be deploying to later in order to generate the actual update script. So none of the scripts that we put in source control will actually get executed on the target environments. It will be the responsibility of the compare engine to generate that update script when it comes to deployment. So I'm going to go ahead and write my check-in comment here. So we added a new contact type and alter the USP.
Okay. Hey, Arne, while you commit that, let me pop up well, let you finish the comment. I'll pop up a poll right after this because we're curious how many of you are using a version control system and which ones you're using. So go ahead and let's commit that and push that.
Okay, so I'm going to commit this to my local. And SQL Source Control should also give me the option to push these changes to GitHub. So once gone through the updating source control, then it's going to give me the option to do a push here. So here I have the option to push. I'm going to go ahead and push the changes from my local to GitHub into the same branch, which is the feature A branch.
All right, let me pop my poll up real quick.
Sounds good.
All right, so if any of you using source control or version control or not using it, please, we'd be curious to know. While they're doing it, Arne, a couple questions. Somebody asked, when we're using source control then, or SQL source control, we're replacing database projects. If somebody's using database projects, they would replace this, correct?
Yeah. Mm-hmm.
Yeah, so I mean, we just have a different format, so that's the issue. And then somebody else asked, when we're using the source control, are we always linking to the development environment, and how you kind of do your initial commit there? I'm just curious. I had an answer, but what would you say there?
Yeah, really good question there. So so the process of, first of all, linking a database to source control is very straightforward. So if I pick a database that is not linked to source control, you simply just go through this wizard here on the Setup tab of SQL Source Control. So you say link to my source control system, hit next, pick the source control system that you're working with, and then so if it's Git, you pick Git, hit next, point you to the repository, to your local repository. So you should have a local Git repository already set up in order to link this database to that repository. So you just put the path to your repository there and then hit link. Once you've linked the database to your repository, if it's an empty repository, then once you visit the commit changes tab, that will show you all the objects on your database that you can commit to that repository, which becomes your initial commit. From there, once everything is committed to source control, then you can start making changes to the database and committing those incremental changes into the same repository.
Okay. Yeah, and the thing I mentioned too is that somebody has said, well, what if I'm trying to get out of production? And you could certainly link to production for that initial commit, but then you would want to delink and link your development database only to the repository. You don't want to have your production linked to the repository.
Exactly, yeah. So only for restoring purposes or creating a baseline, that's totally fine. And then once you do that and you relink the database to your development, then you can use this get latest to bring anything that is missing from your development environment that you brought from production into source control down to your development database.
Right. And so the results of the poll, I don't know if you saw any, but most people use TFS or Git, with a smaller number using SVN or something else.
Okay,
So,
great. Yeah, I mean, that's it's no surprise to us. I think TFS and Git are definitely the most popular ones that we see out there. So great. Okay, cool. So so going back to source control. So this is what the current state of our repository looks like. So master is still pointing to the previous commit, but feature A is now pointing to the new commit that we just made to our repository under the feature A branch. And the head pointer is simply another pointer that shows exactly which feature or which branch you're currently on. So when you do a checkout on a specific branch, this head pointer will move to that branch that you're on. So if I show you my repository, so we've committed those changes into the feature A branch, but my build process actually starts when I merge changes into my master branch. So that's what I'm going to do next here. So I'm going to switch my screen here real quick. And I'll do that again through source tree. So I'm going to switch to my master branch. You can see it also updated the commit that we just did. So I'm going to switch to master. And again, you can see that it's pointing to the previous commit. So feature A is one commit ahead of master. So I'm going to go ahead and merge that commit into the master branch. So I can just simply hit merge and pick the commit that I want to merge into master. And you can see here at the bottom the files that are going to be affected as a result of this. So the contact type data table, the data .SQL file. So we're adding the new contact type here. And also the store procedure. So we've added those columns to the store procedure. So everything looks good. So I'm going to go ahead and merge into my master branch. And once I go ahead and push this to the master in GitHub, that's going to trigger a build in Jenkins. So go ahead and push to master. Okay, so that's done. Now basically what that means is both master and feature A branches are pointing to that new commit that we just did, but master is not our current branch, so the head pointer is pointing to master. Okay, so now that's done, that's going to trigger a build in our CI environment. So again, Jenkins is the tool that we're using for the purpose of this demo. So I'm going to bring Jenkins over here so we can see exactly what's happening with the database. So I've set up my build process to pull the repository and pull the repository every minute and then trigger a build if there's new changes in the repository. So the project that I'm working with here is the AdventureWorks Git project. You can see there's now, it's got into build queue and the build actually just started. So this is the project that we're working with, AdventureWorks Git. While the build is running, I'll quickly walk you through the build steps that I've configured for this database. So go to configure. Okay, so you can see it's pointing to my GitHub repository, and we're building from the master branch, so builds only occur when I'm merging to master. You can do builds on multiple branches if you want, so if feature A is actually a big project, and we're going to be working on that for a couple of months, it's very important for you to also do builds on that branch. So every time you commit changes to the branch, those changes get validated on the feature A branch. So if there's any errors or anything like that, you catch those early before you even merge to master as part of your branching strategy. So so scrolling down, here are the build steps that I've configured for my database. So currently these are just database steps. I don't have any application code steps in here, but if you want, you can actually do both your application build and a database build as part of the same job in Jenkins. So So as part of step 1, I'm doing a schema validation. So there are commandlets that we offer as part of our DLM automation. Um, so these are PowerShell commandlets that you can use to either define or configure your build steps or even your release steps in any release environment that does accept PowerShell as a command line. So you have two options when working with DLM automation. You can either use our plugins for different build systems. So we offer plugins for Jenkins, TeamCity, TFS, Bamboo, or the other option is to use our PowerShell commandlets to define those same steps. So in this case, I've used the PowerShell commandlets because I'm more comfortable with the PowerShell commandlets that we offer, and it's easier to customize it. So the first step is the schema validation step, which basically does the build for the database. So it goes ahead and tries to build the database that we have in source control from scratch on a temporary database. And that temporary database can either be on local DB, which is SQL Server Express that gets installed as part of our DLM automation, or you can point it to a specific instance of SQL Server and create that temporary build there. And that temporary database, once it's built, then it gets dropped on every build, and it goes through the same process every time a build is triggered. So it creates that temporary database, make sure that all the objects are still valid, there's no broken dependency as a result of the changes that you've introduced, and also that there's no syntax or compilation errors with any of the SQL files that you have in source control. Once that build succeeds and the temporary database is created successfully, then we go ahead and package up the database files into a NuGet package, which becomes the lockdown version of what we have in source control. So all those create scripts and the insert scripts that we have in source control get packaged up into a NuGet package, which later can be used as a deployment artifact or a source of deployment going to our higher environment. So we're creating a new package with this name, and the version number is created dynamically based on the build number that we ran. And then once the package is created, then I just save it to disk, and that basically summarizes our build step. I also have a couple of other steps here. So the next step is the invoke DLM database test. So this enables you to run a set of automated tests on your database. So there's two testing frameworks that we support as part of this process. One is called SQL Cop. So if I go back to my database here, and under store procedures, you can see I've got a bunch of objects starting with the SQL Cop schema. So SQL Cop provides you with a set of out-of-box tests that you can use to do some code analysis, make sure that you're following best practices as far as naming objects or making database changes. And there's also some performance tests that you can also utilize, such as fragmented indexes and a couple of other type of tests that you can use. The good thing about this is that these are all store procedures, so if you want to customize any of these tests, you can just simply modify these store procedures and check them into source control, and the automated process will check for any tests that start with SQL Cop schema and will run those automatically as part of your build process. You can also run these tests manually using SQL tests. So all of these tools that we've covered so far, they come as part of the SQL tool belt. So you can utilize any of the tools that we are demoing today. So SQL test enables you to run those tests manually through SSMS on your development machine, or you can use the test option in the build process to automatically run those tests as part of the build. The other framework is TSQL-T. So TSQL-T provides you with these objects that you can use to create unit tests for testing the business logic of your database, such as store procedures, functions. With TSQL-T, there is actually a bit of learning curve because you need to learn and know exactly what each of these framework objects do, and you will be using this framework objects to create your own unit test, which is another set of store procedures that you would create based on this framework object. In this case, I'm only running the SQL Cop test as part of my automated test process in the build, so I don't actually have any unit tests defined on the database. Okay. Go back to our repository, our build process. So that's basically the test step, and then finally once the test step is successful and all the tests pass, then we go ahead and send the NuGet package to our NuGet repository, which is used by Octopus Deploy. So again, Octopus Deploy is the release management tool that we'll be using to deploy changes to our higher environments. So we're just simply sending the NuGet package to the repository that Octopus Deploy uses to locate the NuGet packages. You could also do your releases through Jenkins, but I personally prefer release management tools because they're specifically designed for managing your releases, so you can version your releases easily, and you get a nice dashboard of what releases you've deployed to which environment under different projects. But if you want to use the PowerShell commandlet to do deployments from Jenkins, then that's totally fine as well. So here you can see I've got a bunch of steps for deploying the project to different environments. But because Jenkins is mainly designed for build and continuous integration, I prefer to use a release management tool to better manage my releases. So if I go to my project here, let's make sure that our build succeeded. So yeah, you can see our build was successful. And if you look at the report here real quick, so you can see that the schema validation was successful, which was that temporary database that we built on, in this case, on my local instance of SQL Server. And then we went ahead and ran a set of tests, so all the tests passed. And then finally published the NuGet package to the NuGet repository used by Octopus Deploy. So now if I switch to Octopus Deploy, so for those of you who are...
Actually, Arne, hold on a minute. Let me see how many people are actually using CI/CD. We've got a poll.
Oh yeah, sounds good.
And then I got a couple questions while the poll's running. So somebody was asking about pull requests. So can we still use pull requests with doing the build like this and doing the kind of the commit and push?
Yeah, totally. So when you're doing pull requests, you would be doing those. So you would be doing those from either your Git client or your the Git command line. So from your Git client, you can just simply do a pull request on the stuff that you've saved into your local repository, and then once the pull request is approved or accepted, then that will go ahead and do the push. So you can totally do that, but it will be done through your either your Git command line or whatever Git client tool it is that you're using.
Okay, good. I've got a couple more questions, but hold off. Go ahead and jump to your Octopus, and let's keep going.
Sounds good. Okay, so here's Octopus Deploy. So this is my deployment dashboard. You can see I have different projects, and I have my environments defined. You're looking at this dashboard, I can easily see exactly what releases I've pushed to which environment and which ones were successful or failed. So the project we're working with today is the AdventureWorks Git project. So I'm going to go ahead and create a new release under this project. So you can see it's now showing my NuGet package version as 1.77, which is the package that came from our build that just succeeded. So I'm going to use that package as the source of my deployment going into my hard environment. So the release version is created automatically, but if you want to follow a specific naming convention, then you can just modify that manually. So go ahead and save this. And now I can go ahead and deploy this to my testing environment. And while I'm deploying, I'll quickly run you through the deployment steps that we've configured for our database here. Okay, so if I go to my process tab here. So we also do provide a step template for Octopus Deploy that you can use as opposed to the PowerShell commandlet that we offer. So DLM Automation provides you with the commandlets for both doing builds and releases as part of an automated process. So if you don't want to use the PowerShell commandlet and you're using Octopus Deploy, then you can use our step template, which is basically a wrapper around those PowerShell commandlets. So in this case, I'm using some of those PowerShell commandlets provided by Redgate. So the first step is simply extracting the content of the NuGet package. The NuGet package is just like a zip file. So the first thing we need to do is to extract the content on the target server. And and then we go through the steps of what we need to do with those files that we've extracted from the NuGet package. So the first step, number 2, is deploy from package. This is just one of our step templates that we offer, and you can see that this step only applies to my testing environment. So what we do as part of this step is running a comparison between the state of the database that is in our NuGet package, so all those create scripts and the insert scripts, against our target database, so the testing database. And based on that comparison, it generates an update script, and it runs that update script on our target environment. So everything is done under this single step, so there is no review step or no artifacts that we can review as part of this deployment, which is fine for my testing environment. But when it comes to my staging and production environment, I do things slightly differently. So you can see the first step here is called create database release. This basically does the same comparison between the NuGet package and my staging database. And once the comparison is done, it generates a report of, first of all, what type of changes we're pushing to the target environment and what the update script for those changes looks like. Once that report is generated, then I have a manual intervention step. So this is an Octopus Deploy step. It's not Redgate. I have a manual intervention step where I can review the report before it gets executed, before that update script gets executed on my target environment. So we review the changes. If we're happy, then we approve it. Then it moves on to the next step, which is simply the execution of the update script that we generated as part of step 3. So these are basically the steps in a nutshell. Obviously, all of these steps can be customized. You can add more steps, such as, if you want to back up the database before you deploy, or if you have a bunch of pre-deployment steps that you want to go through, or post-deployment steps, you can totally add those to your release process using PowerShell. So if I go back to my dashboard, you can see the deployment to my testing environment succeeded. So testing is now fully updated. So now I want to go ahead and promote those changes from testing to my staging environment, where we'll actually get a chance to take a look at that report and review the deployment before it gets deployed to the staging environment. So I'm going to go ahead and deploy that now. So this is going to go ahead and start going through the steps that we just went through. And while that's running, I'll also introduce you to another one of our tools called DLM Dashboard. So let me bring DLM Dashboard over here. So DLM Dashboard is a schema monitoring tool which enables you to monitor the schema changes that are introduced to your databases in different environments. The main use case for DLM Dashboard is to detect drift. So if someone goes into production and makes a direct change to your production environment without going through this process, then that will basically show show a drift on that specific database where the direct change was made. So, here's our AdventureWorks 2012 Git pipeline. So you can see we have testing, staging, production. Testing, is currently sitting on the release that we just pushed out to our Octopus Deploy, through our Octopus Deploy. So if I click on this should show me the schema changes that were deployed as part of this release. So if I click on see changes for this one. Okay, so you can first of all see where what type of changes were introduced. So there was one store procedure that was modified. You can see where the changes came from or which user. So in this case, I'm using, this would be the account user that your automated build process or your automated release process is using in the background. So my agent or my Octopus Deploy agent or tentacle uses my Active Directory account. So that's why I changed my name there. So here's the store procedure that has been modified. So you can see exactly what has changed on the database or the object, going from the previous version to the current version. And you can also see where that change, how that change was made. So this came from our DLM automation. If it was done directly from SSMS, then it would show SSMS as the method of the SQL execution. Okay, so everything looks good there. Going back to Octopus Deploy, you can see that now we have the deployment has stopped, and we have some changes to review before it actually gets deployed to our environment. So under artifacts here, you can see we have this changes to HTML file. And if I open up this file, it's going to show us a report of what changes are being deployed to this environment. So if I go to the Changes tab, here it shows you the type of changes that are going to be made to the target database. So we made a couple of modifications to existing objects and data. So here's the USB get contacts and how it's going to be modified. So this is not the deployment script. It's just showing you how the object definition is now is going to change. And the data as well. So here's the new record that we added to that contact type table. So there's obviously 3 different types of changes you can introduce. You can either create new objects or drop objects or modify existing objects. In this case, we just had modifications. But if you are actually dropping objects and specifically tables or anything that could result into data loss, you would actually see warnings in the warning tab here. So currently there is no major warnings here, so everything looks good. And then finally the deployment script. So here's the alter for that store procedure because it already exists in our target, and here's the insert for that new record that we added. So everything is encapsulated into a single transaction. So if the deployment fails while executing the script, then it will roll back the transaction to the beginning. So that way it doesn't leave your target environment in an inconsistent state. So everything looks good here. So we reviewed our deployment. Now I can go ahead and approve this. So it can go ahead and execute the update script on my staging environment. So you can write a detailed comment, especially if you are rejecting the deployment, then you need to make good notes. So that way anyone, the team can take a look at your notes and know exactly what changes they need to make in order to get an approval for the deployment to staging or production. So now it's going to go ahead and take that update.sql file and execute it on my staging database. Another good thing about this is that you can also keep an audit trail of exactly what releases you've done and what was included as part of each release. So for instance, if I go back to my release number 60, that will show me the update script and the changes that were made as part of this release to my database. So this also can be used for rollback purposes. So if you want to roll back your deployment, you can just simply point it to an older release and redeploy that release to your environment. So basically what it's going to do is that it's going to run a comparison between the NuGet package from that specific release against the current state of your database. And based on that comparison, it's going to give you a new script which can be used as a rollback script. You can either build that into the automated process, so your rollback scripts are created automatically, or you can just do it manually by pointing to an older release and redeploying that release to your environment. Okay, so let's go back to our dashboard. You can see the deployment to our staging environment is also successful. So now I can go ahead and promote that to my production environment. So again, as you can see, it makes it really easy for you to deploy. You can just trigger your deployments by a single click of a button, but by having the right review steps in place, specifically for your production or the more important environment. And if you're doing this more frequently, then that means there's smaller units of changes going every time, and that means your review will take less time. And if there's anything that needs to be changed, troubleshooting those will also take a lot less time as well. So it looks like we have about 10 minutes. So I think at this point it makes sense to open up to questions, see if there's any questions actually pending that we need to answer.
Okay. Yeah, I've answered a few, but there's a few that might be good to put out there. So somebody just asked, how do you control third-party database changes? Do you load that to source control? What would you do? I assume something like Dynamics or SAP or something along those lines.
Yeah. So so any changes that are made to your development database, regardless of where they came from. As soon as the changes are introduced to your development database in SQL Server, SQL Source Control will pick up those changes either on whoever's machine has SQL Source Control installed. So if there's third-party changes coming to your development database, then as soon as those changes are made to the database, once you go to the commit tab of your SQL Source Control, that will also include the changes that were made by everyone else. But the commit tab will only have your changes selected by default if you link the database under the shared model. So when you're actually linking the database to Source Control, something I forgot to mention is that there are two options that you can select as far as your development model. So if I click on, go back to here. So you can see there's dedicated database model and then there's shared model. Dedicated means you're the only person making changes to the database. Shared means there are other developers also making changes to that development database. So if you're under this model, you would still see the changes made by the third party, but those changes will not be selected by default when you go to the commit tab. So if you want to check in those changes for them, that's totally fine. But essentially, if if you're bringing in consultants or anyone else that needs to make changes, if they're making a lot of changes, then it would be important for to let them commit their changes into Source Control as part of this process, as opposed to someone else committing for them.
Okay, that's good. Somebody else asked how. Well, okay. So let's take a few of these in order. So can you use SQL Source Control with Bamboo without DLM automation?
No. So basically what we offer as part of, so Bamboo doesn't have any built-in steps for your database. So once you check in your changes in Bamboo, then you would have to have the right process or the build steps or the release steps in Bamboo in order to do this. So that's where DLM automation comes into play. So DLM automation helps you define and configure those build and release steps specifically for your database. And you can either, again, use our Bamboo plugin, which you can download from the Bamboo Marketplace, or you can just use our DLM automation and the commandlets, use the commandlets, the PowerShell commandlets from our DLM automation to define those steps.
Okay. Getting my things jumping around, so you got lots of questions. How are the data migration scripts handled when you do the deployment?
Really, really good question. So one feature that we actually didn't touch on as part of this demo was the migrations feature of SQL Source Control. So the migrations feature of SQL Source Control enables you to provide either one of data migration scripts that are purely DML, or even replace the default behavior of compare on specific schema changes that you make to your database. So this top option here which says start with a blank script, this is mainly used for DML, or if you want to do data fixes or data migrations, then you can save those scripts up as blank scripts. And our compare process uses a metadata table in your target environment to basically keep track of which of these migration scripts have already been executed and which one of these migrations are pending to go as part of the next release. And then the bottom option here is mainly used for cases when you make a schema change, but that schema change also requires some data changes to go with it. So if you're using, the compare engine would only pick up the schema changes, but not necessarily the data changes that need to go with it. So one example of that type of change is refactoring changes that you make to your tables, right? If you're adding a not null column, or if you're splitting a column into two, you obviously need to take care of the existing data that exists in the target environment and make the right changes to that data as part of the process as well. So what you would do there, once you apply the changes to your dev environment, then this will basically show the object that has been changed, so the table, and then you can go ahead and override the default behavior of compare by providing an actual script that compare would need to execute in order to apply that change. So again, all of these changes are stored in Source Control under the Custom Scripts tab. So if I bring up the Works here, there is a subfolder called Custom Scripts, which is where we store those migration scripts. And the migration scripts are executed in the order that they're committed to source control. But if for any reason you want to change that order, then you can modify this deployment order.json file to reorder the scripts as part of your deployment process.
Okay. Somebody asked about Git Flow and doing database changes.
Mm-hmm.
Have you ever talked to anybody or worked with Git Flow?
So once your changes are basically checked into your Git repository, then you can basically go through whatever Git flow that you have in place for either to go through different branches or anything else. So what our tool mainly helps you with is just getting those database changes into your local repository. Once the changes are in your local repository and in whatever branch that you're currently on, then from there you can just follow whatever process that you have in place as part of your Git flow.
Okay, good. Let's see, what else is still open? Could you deploy the DLM tools and steps? So, it says, for example, once you have source control, can you install Jenkins and get CI layer? And then how would you deploy from there? And then if you have that working, then could you install Octopus Deploy and then start deploying there? Kind of how would you implement this? How do you recommend that?
Yeah, so actually what we do offer as part of onboarding either new customers or existing customers who are looking at DLM is helping them actually a screen share session where we actually help them get things configured on their end. So we normally start with a 2-hour session and then we go from there. So what needs to happen basically, first thing that needs to happen is that you need to get your database changes into source control. So set up your source control repository, use SQL Source Control to get those changes into your repository, make sure that you're comfortable with that part of the process and that you're able to successfully check in your changes into source control. Once that's done, then basically start looking into the CI process. So if you don't have a CI tool installed, then that would be the first step. So go ahead and get Jenkins or TeamCD, Bamboo, or whatever CI system it is that you want to use installed either on a dedicated server or on a server that you might have access to. And then once that's done, then you would need to install our DLM Automation as part of our SQL Toolbelt. So just run the SQL Toolbelt installer and install DLM Automation on that box where your build agents are installed as part of your build tool. And then once that's done, then you can start configuring your build steps in the CI environment. So go ahead and configure the build steps, run a build on what you already have in source control to make sure that that database that you put in source control can actually get built and that there's no compilation or validation errors. Once you get a successful build and you have a package in hand, then you can use that package as a source of deployment. So then either go ahead and use your CI system to define your deployment steps, or use a specific release management tool to define your deployment steps and then go through the same process. So again, that's something that we can actually help you with and set up a project around it, work with you on screen share to get things configured.
All right, I think we're just about out of time, Arne. Why don't we flip back to slides real quick? There are some more questions which I'll try to get answered, but I think we need to knock off the webinar here.
Exactly, yeah, sounds good.
So, if you've got more questions that aren't answered, please feel free to contact us. We've got database DevOps at redgate.com. We've got various links for solutions. We do have consultant partners that can help you implement this or work with you to do a DLM type process for your database, whether you're going to use Redgate or not. We do have online training as well from one of our former sales engineers and some other partners so that you can learn more about this and see it more in depth and how these work. In an hour, this is a lot to go through, and I know Arne is kind of going quickly to get things done, but please feel free. There's other resources. There is a webinar next week as well. There's a DevOps 101 webinar that, Arne, if you flip one more slide, I think we've got it on there. Next Wednesday, I think it's the same time. I forget how many hours I'm off from GMT right now, but next Wednesday there's a DevOps 101 from the DevOps guys who are one of our partners, and They are a fantastic consultant company in the UK that has done some amazing things with both application and database software for their clients. So I would encourage you to do that. Again, this webinar is recorded, so we will get it posted on our YouTube channel probably either later this week or early next week, and we'll also put the FAQ up there with all the questions and answers from things that we've answered. So everybody should get an email, and feel free to check that out later. We are doing these webinars monthly, and next month we'll try something a little bit different. And then somebody asked if we would do a migration script webinar, so I think maybe March or April we'll probably just do a DevOps webinar just on migrations, and we'll kind of gloss over the CI/CD part of that a little bit. So anyways, thanks everybody for joining us. Arne, thanks. Great job as usual, and I will talk to you soon.
Yeah, thank you, Steve. Thanks, everyone. Hope you have a good day.